So in this lesson, we are going to learn about the ladder problem. Okay, this is from mechanics, topic moment, A level. Remember, if uniform ladder is given, then weight of the ladder will be in the middle. Okay, and here I have taken length of the ladder 4 meter. Here, bottom bit of the ladder is tied with the string and tension is T. This is what we need to calculate. And its weight is acting in the middle. So its weight is suppose 20. So let's take here 20 G. Okay. Ladder weight is 20 kg. So I have taken here 20 G. And length is 4 meter. So it will be in the middle. So it should be 2 meter until here. And 2 meter here. Okay. Now, there will be some forces here. So let's write down those forces. So here it will be a reaction force from the wall. Okay, so let's write down here, this is the reaction force, and there's another reaction force is here. Okay, so suppose this is your R1 and this is your R2. They all are in Newton, R1 Newton and R2 Newton. These are the reaction force. Okay, now when we are doing the moment, because we need to find the tension here, so what we can do, we can take the moment about the point A. This is point A and point B. So I'm taking moment at point A. Okay, when you're taking moment about the point A, so moment is the force and multiplied by the particular perpendicular distance, right? So there are two types of moment. One is clockwise moment. I'll explain you. Other one is anti-clockwise moment. Okay, so let's write down what is clockwise moment here. Okay, so for clockwise moment, let's take this 20 G. Okay, so 20 G will be turning this side because our A is here. So this is the point we are taking on. So A here, 20 G is turning that side. Then our tension T is also turning this side. So these are your clockwise moment, right? So let's write down here. Let's take T first. So T times perpendicular distance. For T, what should be the perpendicular distance here? So let's see the perpendicular distance for T. So this is T, then perpendicular distance will be this yellow line, right? Okay, so T is going here, so perpendicular distance will be this. So this angle is given here 70 degree, yeah? So we can find it using SOHCAHTOA. So let's find out here. So question, we can do it. So we can find out here. So this is a triangle, right? And this is 70 degree. Okay, this is 70 degree and we need to find the perpendicular distance here, right? So suppose this distance is X here and this distance is Y, right? So we need to find this green distance, perpendicular distance. So let me make here zigzag line. Okay, so this we need to find perpendicular distance. See, it is making 90 degree. So and this we have taken here X and this is 4. So sine 70 equal to X over 4. Perpendicular distance will be X equal to 4 times 70. So it should be T times 4 sine 70. Another clockwise moment is 20 G. So from 20 G we can take it. So that is 20 G. So for 20 G, what should be the perpendicular distance? This again. So this zigzag, this will be a perpendicular distance. This is 70 degree. So this is also 70 degree. Now we need to find this is Y. So Y will be here 2 cos 70 degree because we are taking this triangle. So here it is 2 cos 70 degree. So it should be 2 cos 70 degree. Because ladder is in equilibrium, so we'll put equal sign. Now anti-clockwise moment. So anti-clockwise moment, this is the only moment R2 is going like this towards it. So it is anti-clockwise moment. So we can write down here R2. And with R2, what should be the perpendicular distance? This will be the perpendicular distance here. Okay, so it should be again, if you take the triangle here and this is 4 and this is 70 degree, and if suppose this distance is P, so it should be 4 cos 70 degree. So R2 times 4 cos 70 degree. Is that okay? Now, what should be the R2? R2 is upward force and 20G is acting down. So 20G is here, R2 is here. So R2 equal to 20G. So we can write down here R2 as 20G. So this should be 20G times 4 cos 70, and here it should be 40 sin 70 plus 20G times 2 cos 70. Okay, so let's put the value in the calculator. So 40 sin 70 will be 0.93. 20 times G times 2 times cos 70, it should be 134. 20 times G times 4 times cos 70, it should be 268.14. If we do minus 134 both sides, so we are left with 134.14, and it is 40 times 0.93. So what should be the value of T? T is 134.14 divided by 4 times 0.93, and if you simplify, it will be nearly 36 Newton tension. Okay.